Hi, this is Bill Foote, and this is Informing Decisions. This is our third in a series of installments based upon the book Informing Decisions using spreadsheets. And this time, we're going to build on what we just did, and that's what's going to happen throughout this sequence. We're going to still be pricing pi, yes. Madame Portier and her CFO, Fozzie. I don't remember her name. It's in the book. But this time we're going to consider the effect of time. We're going to take weekly, and then we're going to create annual versions of everything. There's a decision that they're also going to be making within the pricing decision. But yeah, here we go. Best laid plans of mice and the humanoids. We got a great plan in the background there. But this is what we come up with. Well, we're going to try to straighten this rocket out a little bit as we go through the second part of our spreadsheet engineering sequence. The first one, again, was the weekly pie, created a dashboard. Oh my gosh, with slide bars, and more importantly, named ranges were used. And these are very similar to the names we would give variables in an algebraic equation, for example. But they also are kind of like an internal documentation. The named range in Excel and Old Lotus and other spreadsheet environments would locate an array or one cell and freeze it, called an absolute reference. And this is really useful to the analyst because you don't have to go hunting back for where is K6. Well, it's in worksheet 4. Comes from worksheet 4, and where is that? And AA 341. I mean that's crazy to do that. But we do it anyways because we're usually building spreadsheets quickly as proofs of concept, if anything, and they're extremely good for that kind of environment. We're also going to eventually use something called indirect, where we can put the name of a range in a cell, choose it, and then all the formulas would say, go to the name range in that cell. This way we can create lists and provide much more interactivity, which is an extremely desired feature in any model, especially ones where decision makers need to literally play around and have discussions about how different values, when they change, produce different outcomes, input, process, output. We're also going to be using some product as we go through. This is a non-probabilistic sensitivity analysis. Well, actually, it's a probabilistic one if we consider that every single scenario is equally likely. We just imposed a probabilistic interpretation, but it's not in the model. It's something that we impose on the outside. Right? It's not reality. We don't know what reality might be in this case, but it is something we impose on it for analytical, again, not rigor, but analytical possibility. You can ask questions about, well, how likely is that sensitivity? And that's where we get our notion in statistics, certainly, of expected value and ranges of expected value. Yeah, we're going to use a data table there. We can also do that with VBA. That's in the book. I want to emphasize that what we're going to do next here is a one variable optimization using a technique called grid approximation. Then we're going to plot and make a dashboard again, okay? But we're going to build on what we did last week. Pretty much the same thing. The big change here, the big change, is an extension of weeks into years. We're going to create an annualized version of the model with some more assumptions following our map built out of the 4-cause analysis. Our map is something like an influence diagram. And there's actually quite a relationship between influence diagrams and those decision trees that we saw in the teaser, the very first lecture in the sequence. And of course, lots of operational assumptions, and decision value will be net present value, a finance term. The finance term comes out naturally when we think about time and how value grows or declines over time. That's all that an interest rate really is. It's a rate of growth. That's a very natural in the sense that I'm 5 feet 11 inches. I was not always 5 feet 11 inches. I grew. There is a rate of change. And that's a concept we can use throughout this model building that we're doing. And then where do we go from here? Yeah, where are we going to go from here? Again, the pricing decision with the 4 causes and the formal cause, the imperial cause. And we still need to think about these things as we build the model because we have to literally test ourselves, quiz ourselves. Why do I have that piece in there? Now, that's what the imperial cause. How is it I don't have a lot of other things in this model, which are really cool things, perhaps? And a lot of people say, well, that's a science experiment. Well, yeah, actually it is. About everything we do is a science experiment. We're trying something out, but in the end, we're going to just do a set list. Okay, the set list at the concert, right? Just some of the songs out of the entire book of songs that we have. What's the process? And the process here is incredibly simple, but the process is embedded in the influence diagram itself. What's the purpose? Well, here I'm gonna kind of come to the bottom of this list. Enough profit to fund future operations and growth without abridging quality and consumer value. I mean, to me, that's what every business ought to do. Define the consumer, define quality, put operations against that. It means you have to invest, put contracts in place, become the trusted provider. And again, falling back on Goethe's idea as opposed to bacon and eggs up there, bacon and Newton. You could either take the glass is half full, or you can take the glass is half empty. And when we're looking at complex organisms like social organizations, well, organizations pretty social. Social organizations with human decision makers, very complex. We need to take the whole over the fragments. And the thing is, each of the fragments has some aspect of the whole in it. And here we have the whole organization. Why is it? And actually, the whole organization is embedded in a much larger, we often call it an ecosystem of all sorts of stakeholders and decisions. Now, I mean, after a while, we do have to cut this down so that we can touch the tree, so we can, prune it a little bit and see what the heck is really going on. Yes. Again, here is by process, farmer, down to food, fudge. Now, the fudge inside of this is going to be very interesting. There is a bit of fudge we're going to use. We're going to use something called rate of value growth in our model. And here it is. V0 is, well, 0 is today, 1 is tomorrow. This could be T and T plus 1. Year 2022, year 2023. This is all we need, just to, get our bearings here and look at the navigational beacons here, and somehow we're going to steer our way through them. But it comes out of the notion of value comes out of this first equation, V1. How is V1 determined? Well, V0 grows into V1. That's how it happens. And we could mathematically express this as, well, we start off with V0, and then it grows at a rate R. So we add some growth here. It's value additivity at its finest. Then just because we know a little algebra, that future value is equal to the present value times 1 plus the growth rate. Oh, and then doing a little bit more algebra, we can find the present value and isolate it by dividing both sides by 1 plus R. And 1 plus R over 1 plus R is always going to be equal to 1. And anything times 1 is itself. Okay, there we go, a little algebra. And we have V0 is V1 over 1 plus R. This is the fundamental valuation equation of finance, but anything that grows, basically. V could be a number of lives saved by investments in healthcare. That could be it. Could be exactly how many lives do we need to save, right? Or this could be a savings account. How much do you have to deposit into a savings account in order to make a certain sum, V1, in the future? Oh, V0 is the number at that rate. Same idea. So we will use this to build this. Now, look at this one. Okay, we have slide bars. We still have slide bars. That allows the anybody who uses this to change the assumptions. That's the key. We want to change the assumptions. We don't have that ability. It's like, so what? This model's a big so what. Okay, that's how it works. We have weekly on the left, 3-year profit, value profit analysis on the right, both of them versus price. Now notice we get positive profit on the week, but when we add in other assumptions, it looks like this is called underwater officially. Curve is a real interesting problem. Yeah. At any price. Wow, we got a problem here. We have things we need to fix. We will fix that in the next installment. Production problem, it turns out, it's the mix of product inputs, and it's the mix of what's being sold. Multiple inputs, multiple outputs, different kinds of pie in our case. And here's something at the bottom. We got some useful tables and so on. This is a net present value heat chart. Some people don't like heat charts. I like it because, well, I can point to green and say, why is that really good? And without having to look at the numbers. And we have prices varying with filling costs of pie. Now, what are the filling costs? Well, it's a fish pie, it's fish, but we don't have fish. Oh, there might be potatoes in it, and maybe they're more expensive and so on. But we boiling it down to filling costs. And now we can see interrelationships, a la Goethe, interrelationships among our assumptions and our choices. The choice is on the left. That's the decision. Which one are you going to choose? Which one is better? Well, the best price is the one that loses the least in this particular case over the 3-year period. And we can see what that best price is relative to changes in, and those filling costs will change over time. We're going to use the same technology we used before for costs. We're going to roll these up. Remember what R squared was. This is really an interpolation. There's a linear interpolation. This is a quadratic interpolation. I'm going to fit this data almost perfectly. You can see the little scatter plot. And I, again, in Excel, I always use scatter plots. I know a lot about the scatter plot. I learned a lot about it. I could even program it at one time. I thought I could do it, but I could get back into it because I documented that process very well. And we have predicted costs. Well, this is old stuff. And the assumption here is the past will be replicated into the future. Be really careful with that one. Okay, things can change. But this is consistent with the data that we do have. And it's a start, that's all. And we did the same with demand. Now, demand on the left is just a very, very simple interpolation. It is rise over run to figure out what the slope of that line would be just for 2 points. Very, very simple. 2 points will determine straight line. We don't have a quadratic here. We don't have enough data to build a quadratic. There might be some bend in that line, yeah, but right now we don't have enough data. We've only done one experiment. This tells me that we probably want to do a couple of other demand experiments in the marketplace and see how sensitive consumers are to this particular decision variable called pricing. And we have our weekly profit model from last week. Notice, there's formatting here, which drives me right to the blue line or right to the pricing decision. Okay, color coding is helpful. And on the right, we actually have documentation of what the formulas are. This is prevailing good recommended practice. This is not leading edge. This is simply prevailing recommended practice. And then we built a very simple grid, max, min, nodes with our width is calculated. We have a 9-node grid on the left with pi prices, and we're not assuming the max or the min of that. We can hard code it. Do not hard code it. Do not hard code it. Somebody's going to come along and say, well, let's zoom in between, let's see, 10. Okay, and then the max would change to 10 and to 8. Then, what I'll be doing is just scrunching this whole graph up. Scrunch. We did all of that. But let's use this net present value idea. And I just want to, there's four steps to this. Suppose we have today is 0, year 1, year 2, and suppose that we take out of our piggy bank $20, 21, 20 pounds, whatever it is, 20 of something. And we have forecasting. This is definitely a forecast because it's now a future. 10 and 15 in the future. 35 if you were to add them up raw. Okay. And one way to express this, and it's a diagram, and I draw it because I think we should draw these things. We have a timeline. We have an arrow going down for things going out of our pockets and an arrow going up for things coming into our pockets. Okay, it's that simple. All right. I use pluses and minuses to do that. Okay, so that's where I'm going to start. I'm going to use this simple example to get us comfortable with the net present value idea. So what's the present value of minus 20 today? That's PV today 0 minus 20. It's equal to 20 divided by 1 plus the interest rate, 1.11. Okay, raised to the what year? 0 power. Well, 20 divided by 1 is just 20. So it just tells you the present value of something today is today. Okay, now that common sense, if it didn't, then we have a problem. Okay, Now, in net present value analysis, you have to include all cash flows, all profits. And what that means is today, next year, the year after, however long you're going to forecast into the future, and then some lump sum at the end we're going to call terminal value to account for the possibility of a very long future. Chief Justice Marshall, the Supreme Court in the 1830s, basically defined the corporation as a legal entity, kind of a fiction of sorts, gathering of people. But basically said this can go on in perpetuity. That's the idea. It has legal standing. That's an old decision. Something to look up, maybe. Talk to your lawyer about. Well, what is the present value today of getting something? What is it? 10? See the plus 10 in red. We're looking for the 9.09. Given that, if we solve that value equation, if we put in $9.09, it will grow approximately at 10% into $10. So working backwards, we start with the 10. See what we do here. See, $9 plus 10% of 9 equals 10. Okay, good. Working backward, you have 10 divided by 1 plus r to the first power. There's only one date there. Okay, there's only one period between, and we discretized it. There's a lot of other stuff that can happen in between, yeah, but we're focusing just on one discrete period, beginning of period, end of period. It happens to be a year in this case. That's 9.09. So that's the idea there. And then taking that same idea, how much do we need today to grow at 10% in 1 year? Take that amount and let it grow another 10% into the second year. Okay. And notice that's 15 plus 15. How much do we need today? Turns out to be 1240. We need today. Now, net present value is adding all of these items together. Present value of all of the cash flows, including today. This you will find out when you look at the subsequent videos for this unit 2, in the playlist. You will find out that Excel's net present value is not this net present value. What do we do then? Well, I don't use it. That's what I don't use it. Too confusing. It's the wrong terminology. I don't know who put it together. I think it was done in 1995 by somebody who didn't understand the financial valuation problem and process. This is actual net present value, not Excel. Don't use PV either. Just do it the way I'm going to show you in the spreadsheet. And here it is, the spreadsheet. Now you can see again, we have formatting. We have number of years. We have year 0, year 1, year 2, year 3. We have model parameters for each year. Notice we have model parameters for each and every year. And the model parameters, notice, is a growth in each parameter. Kind of interesting. There's an inflation. What's the inflation? Here, here, and here. Okay, so these grow at some rate. Oh, here are the inflations. But here are the, in time 0, oh, that's good. I did this right. In time 0, these are the initial values, and then they grow from 0 to 1 to 2 to 3. So we're using growth here, compound growth, okay? Because 401 is 7% greater than 371. Okay. So, go through it. But the idea here is to reverse engineer this for yourself. This is very interesting. If you don't do it yourself, just look at the model that I provide and just try to follow along with it. That's not enough. You actually have to try to replicate this, or else you won't get what's going on. Here's the price that we're solving for. And that comes from, a sensitivity analysis. Oh, wow. That all comes from a sensitivity analysis. Very interesting. Okay, so we have growth rates here, we have initial values here. We bring it all down to a so-called bottom line here for 3 years. And then I think everything stops. It is an assumption in there that you want to explore, by the way. Stops for 3 years. And it is underwater. This thing is underwater with all these complications that we have. And it's annualized. So we have demand, cost. And then we had some materials costs, processing costs, fixed costs. That's a production process itself. You have to find out what people are willing to pay. Well, this is not a going concern. This was an accounting. So anyways, this all gets constructed. We do a sensitivity analysis. This is a one-way table. We have pie prices, but again, we're using max and min, number of nodes, calculating the width between each node. Okay, 9.375 cents. Yeah, and we're getting a maximum profit. And just like we did with the weekly, we're using something called index and match. Match actually brings us to the right row. Okay, the right row. Right. The max of this array, the right row. Right row. Here. Okay. You can play with this. That's the beauty of this. You're getting deeper and deeper in the hole here. It happens to be this one. Row 1. Well, what's row 1 in the prices? It happens to be 875, and it returns this. This is the preferred and very professional, I must say. I have gone back and forth with colleagues, students, my mother, about this versus V lookup or H lookup. They're fine, but they're dangerous. They're dangerous because there's a number in it. It's the match issue that's embedded in it. Here, I have complete control over what that number will be. Complete control. It happens to be the max of something. Max of L6 through L. I could be using name ranges here. Boy, gotta fix this model up. Name ranges for some of these things so that I don't have to figure out where the heck is L6. And then we have a two-way table, which means we have two grids to build. One as columns, filling costs, and the other as prices. Two of them. And we can get the max profit out of, where's the max profit here? And we can play with this. That optimal price was the optimal price overall. Okay. We can do a lot of different things with this. And this to me is where discussions should go, the two-way analysis. It's easy to see. It's not complete. If somebody says, filling costs were really problem last year. We didn't know what they would be. It was highly uncertain, and because we had a pandemic and supplies and so on. We should be very sensitive. Now, I have used exactly this with companies, and it's the one thing that breeds the discussion. Because now we're not all over the table. Yeah, we're all over this table. We're not all over around the conference table, yapping about this, yapping about that. No, we're focused on a discussion of this. We don't like this, put a different thing in there, right? What is the thing? What's the filling cost? Some other thing, like maybe an administrative issue or workers' claim, worker comp claims, which we'll look at. And this particular one, I also built, you can see here, a VBA function. You can investigate, of course, and in the model. Well, what's next after all of this discussion? We have a dashboard. Pricing we figured out. I know we really haven't. We have production timing to think about. We have production sizing and mixing issues, blending issues, quite literally. We're going to look at self-insurance. We're going to look at customer service, just to get a handle on the different varieties of things that can happen to this little company. Happens to all companies and households. That's where we're going to go next. And we've accomplished about the same things as we did before, but building on it. And that's what's going to be next. Next, we're going to actually use a very simple model, linear programming, going to help us do pricing, product mix, all sorts of interesting things, and we can go crazy with that. But we need to crawl, build some psoas muscle core before we stand up and before we walk, before we run. Okay. But we did roots to leaves here. Again, we're always going to use some version of the 4-cause analysis to help us through the process. To make sure we're asking all of the questions before we zoom in on a few focus areas. That's very good. Interactive dashboard, we built a whole new one. Named ranges, formula documentation, modular worksheets, and formatting for clarity and transparency. Okay, those are the 5. 1, 2, 3, 4. Oh, there should be a 5th one. I can't remember what it is, but I will think of it. Okay, but this is the start. Name ranges, document with formula text, modular worksheet for each task, formatting, clarity. Along the way, this time we used a two-way table. Softly treading into things, nurture, do not force. And we're always trying to go from merely how to effectively what if, from mere satisfaction, pat ourselves on the back. No. We need to build scenarios, and we need to be clever about those. Pierre Schwartz and his team for years, I think, built some of the best scenarios I've ever seen in any company at the Royal Dutch Shell, trying to figure out what we're going to do in the future. The economist in me says, well, yeah, there's a rational expectations aspect of this. What I forecast, 2 things. What I forecast into the future, I pound into my decisions today, and it almost seems as if I am making that forecast come true. Rationally, yeah, but other forces can come in and destroy that hope, which means it has to be very dynamic, not myopic. I have extreme myopia, not myopic. Yeah, we need to make corrections for that, and this is only the beginning. Again, a principled way to inform decisions There we go, price and pie in time. That chime tells me I think I've had enough. So go on to the next unit, the same unit as this in the playlist, and look at how I walk through my process of building models. Okay, this time a more complicated model. I think I even have a little bit about VBA in there. Not hard to do. It's a great automation machine inside of Excel. And with that, I'd like to bid you adieu. And again, thank you very much for your kind attention as we um, work through this unit, its models, and begin to think about what we're going to do next. Take care.